Do you know what is a normal distribution? What is the application of that? Hi, my name is Pradeep Chavan. We are going to see normal distribution derivation, how it is derived. Of course, conceptually, we are going to see what is the importance of the normal distribution, what are the usage of the normal distribution. You cannot learn the statistics without normal distribution. So this is so much important. So let us start. Normal distribution is also called as a Bell distribution because it is having the shape like the bell. It is also called as a Gaussian distribution as it is named after German mathematician Mr. Gauss. So basic question, what is a distribution? It is a distribution or the probability of occurrence of the possible outcome from the experiment. What is the meaning of this? If there is a lot which contain the product, if I take few sample from the lot, so what is the probability of getting mean size of the sample, or what is the probability of getting shift of the mean? So all these things we are going to discuss. Here in this video, we are going to see normal distribution is a continuous probability distribution function and often used to approximate discrete distribution. So what is the meaning of this that we are going to see? We are going to see properties of normal distribution, standard normal curve, Z and T distribution. What is that? We are going to see. And most important thing, what is the confidence interval? These are things which we are going to see in this video. To understand normal distribution, let us start with common mathematics or the 12th standard mathematics. Let us take combination. So what is a combination? Selection of atom from a set such that the order of selection does not matter. Let us take one example. There is a tray in which 10 jobs are there. From that, how many different way one job can be selected? Answer is 10 times. So I can select one, I can select second one, third one. So number of group is 1. So 10 different ways are there from which I can select one job from this tree. How many combination? So I can say one combination. Okay, how many combination can be made for the two job? For that we need to have formula, because how many combination for 3 4, that cannot be possible by manual. So we need to have the formula. So formula for the combination is CNR equal to n factorial divided by r factorial n minus r bracket factorial. So what is a factorial? For example, you wanted to calculate the factorial 5, that will be 5 into 4 into 3 into 2 into 1. So this is how factorial it will be calculated. So what is a n? That is a tray, number of things to choose from. So in that example, we are having the 10 job. Number of things chosen from the group size or from that set. So either you can choose one, two, three, but that cannot be more than n. That cannot be more than 10. Okay. Now, if I want to choose two job from the that particular tray or the set, how many combination it can be made, or by how many different way it can be chosen? Formula is this, and we have got 45. So 45's combination are there where I can choose two job from the set of 10 job. Are you getting me? So from this formula, I can calculate combination for anything. Combination for 10 comma 4, that will be 210. So 45 we have seen. So here combination from 0 to 10. So I have calculated by this formula and I have got this value. These are the combination which can be made for this particular thing. So even I can draw the bar chart for this combination. Even line chart can be drawn for this combination. Now let us start with the proportion. How proportion can be calculated? Proportion can be calculated by individual combination can be added first. That is total combination 1024. That will be used for the calculation proportion. How? Now individual combination can be divided by total combination. Then you will get the proportion. For example, 1 divided by this total, you will get this. Then 120 divided by this, you will get 0.11. So proportion, if you add together, that will be 1%. Okay. Now you can draw a line graph for the proportion also. Now try to understand proportion is nothing but the probability. First thing. Now, what is the meaning of this probability or how to interpret? Now, sorry, probability of getting selected individual job in this particular combination of five, for example. So, what is the probability of getting selected individual job in the five is 24.6%. Are you getting me? So, similarly, you can see probability of getting selected in the eight combination, rather eight group, is a 4.3%. So this is a probability of getting selected into particular group. So these are the proportion. Now question is how it can be used for the normal distribution. So let us see. Now central limit theorem is the base for the derivation of the normal distribution. What is the central limit theory? It is a distribution of the average of the large number of distributed random variable approaches a normal distribution regardless of the original distribution of the variable. So it seems very heavy statement, but no, don't worry. So we'll try to simplify. Now, first of all, what is a random variable? Random variable is nothing but the outcome of the random experiment. So this is the outcome. This group are the random variable. So it can be number of jobs characteristic will be the random variable. Now they are saying if you increase the number of bar in layman language you can say, then this will be approximating or it will be going close to the normal distribution. So if I increase the number of graph here, then the curve will be more smooth. And thumb rule or statistically it is proven that minimum 30 samples are there. In this case number of bar, if it is 30, then it will be following the normal distribution properties or the normal distribution curve that will be there. So here normal distribution is a continuous probability distribution function and often used to approximate discrete distribution. Now see at initial stage if there are less random variable then graph will not be smooth. If we increase the number of random variable then graph will be very smooth and that will be giving the standard normal curve, and it is proven that this standard normal curve is having this formula. So one more thing, what is a discrete distribution? We have seen the random variable. So random variable is having two category. One is a discrete variable, second is a continuous variable. Now see, this is a discrete variable. So what is the meaning of this? Now difference between the outcome are meaningful. So either I can get 1, I can get 3, I can get 4, 5. So in between there is a nothing. But if I increase the number of site like this, now still it will be little bit meaningful outcome. But if I increase number of site, it will be going to the sphere. So here number of outcome are meaningless. For example, salary can be 1 lakh per annum, even 1 lakh point 0.0001. So in terms of paisa, 1 paisa is the difference between two salary. So outcome is a not meaningful. So that will be continuous variable. Are you getting me? Let us talk about the properties of normal distribution. Now mean or the median will be at the middle. So this will be the inside area that will be called as a probability area. It will be symmetrical. Lower side tail that will be left one, upper tail that will be right one. So shape is controlled by sigma or the standard deviation. So if standard deviation is more, then shape will be flat, and the standard deviation is less, then shape will be moving vertically up. Now left tail or the right tail will be infinite. It will be never touching to x-axis. Why? Because it is a continuous distribution. Now the difference between two random variable cannot be what I mean to say, it is having n number of division. For example 1 millimeter, but 1 millimeter can be divided into infinity part. So that's why these two tail will never touch x-axis. Okay. So normal distribution will be tend toward the left or right depend upon the mu or the average. For example, mu equal to 0, then it will be lying in the middle, that is orange color. If it is a -5, then it will be shifting toward the left. If it is a mu equal to +5, then it will be shifting toward the right. What is a Z distribution? It is also known as a standard normal distribution. You can say it is a special case of the normal distribution where the mean is 0 and standard deviation is 1. Mu is 0 and standard deviation is 1. So why it is used? For the standardizing the score and making the comparison between different normal distribution. So whenever we are having different normal distribution, it is having standard deviation different, mean different, then how to compare? For that Z distribution is created. So formula for Z distribution is this curve is followed. This formula Z equal to this individual reading minus average divided by sigma. Here the sample, the large our sample size, the more confident we are that is the representative of the entire population. In the larger sample, we are likely to capture the natural variation and diversity in the population data. So there is a point when increasing the sample size offer no statistical benefit. So you can take by thumb rule 30 sample. So if 30 sample is taken, then normal distribution will be followed, and according to Z distribution that can be compared. But even after 30 job or the even after 100 job, so that is no more statistical benefit. Okay. This is the area under curve, that is a normal standard curve and the Z distribution curve. So for the three standard deviation, 99.75 74 percentage area is covered. For the two standard deviation, that is a 95.44 area is there. For the one standard deviation, 68.26 area is covered. Now if you go from the left to right, there you will find here up to middle 50%, and if you go on adding, so that will be, if you draw the graph for that, that will be cumulative. Are you getting me? So here 99.87 percentage area is covered. Okay. There is a one more distribution is a important distribution, that is called T distribution. When sample size is less than 30, then T distribution is followed. So that's why we need to take more than 30 or even up to 100 sample, so that Z distribution and normal distribution will be followed. But because of some practical restriction, if you are taking less than 30, then T distribution will be followed, in which variation will be more, standard deviation will be more. Now here n minus 1 should be considered, that is a degree of freedom. If you take the less sample, then graph will be coming downward, and if you take the sample more than 30, graph will be moving upward. So here you can see this outer line, that is a this one where I am putting the cursor, is a degree of freedom 30. So that is 31 sample. If you take the less sample, then inner graph will be there. So after 30 and above 30, Z distribution and T distribution both will be same. Now let us see how to calculate confidence interval. When confidence interval, if sigma is known. Now let us estimate the mean amount spent per customer at the restaurant. Data was collected for 75 customers. We are to assume the population standard deviation is 4. So at 95% confidence, what is the margin of error? If sample mean is 20, what is a 95% confidence interval for the population mean? So sampling deviation formula is this. So equal to, this is a population deviation divided by root n. N is the number of sample. So in this case, how many number of sample? That is a 75. 75 customer sample was there. So equal to 4. That is a standard deviation from the population divided by under root 75. So we got 0.46. Then point estimate will be z into 1 point z, that is a value having 1.96 into margin of error. So point estimate is a 20 plus minus 20 is a mean. So mean is 20 plus minus 0.91. So how you got 0.91? 1.96 into 0.46. So that is a range, that is 19.09 to 20.91. So please note that Z equal to 1.96 at 95% confidence level. So we have seen our graph. So at 95% confidence level, Z value is 1.96. That's why it is taken 1.96. So this is a confidence interval for 95%. If interval if sigma is known, okay. So here graphical representation of same sample is same example is presented here. Z equal to 1.96 here. This is a minus value, this is a plus value, this is a 95% confidence level. Now Ex plus minus 1.96. Why 1.96? Because at a 95% level it is having that value into standard deviation. So Ex is a 20 plus minus 0.91. So at this particular point Z equal to 1.96 or 95% level value or the point of estimate interval is 19.09 to 20.91. Confidence interval, if sigma is not known, in that case t distribution should be followed. In this case standard deviation will be this, where n will be considered as a degree of freedom, that is n minus 1. Degree of freedom n1 minus 1 will be considered. So here t distribution is represented or the presented in the graphical form. Now same mean is there, that is 20. Degree of freedom you have to consider number of sample are 10. So degree of freedom, that is a 10 minus 1, that is a 9. For 95% confidence interval you have to consider the value of t. From the t distribution or the t table you have to see the value, that is a 2.262 plus 2.26 minus 2.26, and accordingly you have to calculate the error and point will be like this. So this is a confidence interval as per the t distribution. Okay, thank you very much for joining this session. Thank you.